All right, now that we understand our binary ionic nomenclature, let's put that same principle into practice with our polyatomic ions. So it's still going to be ionic nomenclature, except instead of having a cation and an anion that we just figure out from the periodic table, we're going to go ahead and take mostly cations that we figure out from the periodic table, but a whole bunch of these polyatomic anions. So poly meaning many. So these are ions that contain many atoms. Now, most of these will be anions, but if you look at this flow chart here, I do have polyatomic cations mentioned. There's one main polyatomic cation that you're going to need to be responsible for and understand during this course, and that is going to be this one right here, NH4+. Okay, this is ammonium. All right. It's not the only polyatomic cation that exists. It's just there's not very many of them, and this is the only one that I'm going to require you to be responsible for here. Now, when it comes to the polyatomic anions, however, there are tons of these, okay? Now, a whole bunch of them, we're going to be able to use some clues on the periodic table to help us figure out what they are as we start to learn them. And then there's going to be some that, yes, you are just going to have to memorize. So, rote memorization's a thing. Sometimes we just have to memorize things so you can just recall them. And this is going to be one of those times. All right, so when we look at our polyatomic ions, I mentioned before that we need to go ahead and make sure we understand that that ion is a group. It stays together. When I only need one of them, it's easy. I just put the whole thing together. So something like potassium nitrate. Potassium's a +1, nitrate's a -1. Our charge balance works, already cancels out. So my formula is just the potassium ion, the nitrate ion, KNO3. We're done. But when I need more than one of the polyatomic ion, I have to do my charge balancing. And now I have to make sure that my polyatomic ion stays together as a group. So what I do is I put parentheses around the polyatomic ion, and then I put a subscript outside of the parentheses so that I know how many of them that I have. So in this case, calcium nitrate. Calcium's a +2, nitrate's a -1. And so we need 2 of the nitrate groups for every 1 calcium. And so that's why we have 2 nitrates in my calcium nitrate. All right. We're going to talk a lot about oxyanions. These are the ones that we're going to be able to use clues from the periodic table to figure out. So our oxyanions are going to have 2 primary endings, ate and ite. Ate is going to represent more oxygen atoms. Ite is going to represent fewer oxygen atoms. Okay? So oxyanions, these are containing oxygen. All right. The other nice thing about most of these oxyanions, not all of them, but a lot of them, is they will keep the same charge that the monatomic ion keeps. So when I look at phosphorus, it's in group 5A. It needs 3 more valence electrons, and so the phosphide monatomic ion has a -3 charge. Well, when phosphorus makes oxyanions, the oxyanions also have a -3. Okay, so this is going to hold true. So you can see this blue box I have drawn. Everything in that blue box keeps the same charge as the monatomic ion. And then my halogens, the chlorine, the bromine, the iodine, the oxyanions are also going to keep the same charge as my halogens keep. The difference is going to be for our nitrogen, our carbon, and our boron. When nitrogen makes oxyanions, they are going to have a -1 charge. When carbon makes oxyanions, they are going to have a -2 charge. And when boron makes oxyanions, they are going to have a -3 charge. So again, nitrogen containing oxyanions, -1. Carbon containing oxyanions, -2. Boron containing oxyanions, -3. Okay, so we're going to start off dealing with 4 oxygens. Okay? Those that contain 4 oxygens and have an 8 ending are going to be inside that blue box. Now, that blue box kind of looks like the shape of the state of Mississippi. All right, so atoms inside the state of Mississippi, their oxyanions are going to have an 8 ending when they contain 4 oxygens. Okay? Now, outside the state of Mississippi, what I have circled in red, those oxyanions with an 8 ending are going to have 3 oxygen atoms. Okay? So we're dealing with 8 ending first. Atoms inside Mississippi have 4 oxygens. Ions outside Mississippi have 3 oxygens. Okay, the other thing you can do is you can also draw number 4. That's what I like to do. If you draw number 4 through phosphorus, arsenic, sulfur, selenium, and tellurium, that number 4, I like to think as a good visual clue to remember, oh, 4 oxygens is my 8 ending. And then the ones outside of that have 3 oxygens. Okay, so let's practice a couple. All right, again, we're dealing with our 8 ending. All right, so here I have a calcium and then that ClO3. So remember, chlorine was outside of Mississippi or outside the number 4. And so its 8 ion has 3. So this is calcium chlorate. Okay, my next one, I've got a sodium cation and then that SO4. So sulfur was inside that number 4 Mississippi box. And so for the ones inside, our 8 ending have 4 oxygens. So my SO4 gives me sodium sulfate. Okay, next up, Mg is magnesium. Okay, so my 8 for phosphorus has 4 oxygens, so this is magnesium phosphate. And then my last one there, I've got aluminum and then bromines outside of Mississippi, and so for our 8, we have 3 oxygens. So we get aluminum bromate. Okay, we can go the other way around. We can figure out what our formula is. Okay, so lithium, we get an Li with a +1. Selenate, so selenium is inside my Mississippi box, and so we're going to get an SeO4. Okay, and it also keeps that charge of its group, so it has a -2 like the selenide ion does, and so we get Li2SeO4 for our charge balancing. So I need 2 lithiums because they're only a +1, and I only need 1 selenate because it's a -2. All right, so potassium iodate. So potassium is a +1. Okay, iodine is outside of my Mississippi, so my 8 ion has 3 oxygens. So this is going to be IO3. And it also keeps that monatomic ion charge. So it's a -1. This one's nice. +1 -1 is going to give me KiO3. Okay, aluminum. Okay, and then carbonate. So carbon is outside my Mississippi. So my 8 ion has only 3 oxygens. And then I mentioned that carbon oxyanions don't keep the group charge. And so nitrogen oxyanions are -1, carbon oxyanions are -2. So this is going to be a -2. Okay? When we do our charge balance, okay, 6 is going to be my common number for these. So 6 divided by 3 gives me 2. So I'm going to take 2 aluminums. And then 6 divided by 3 is going to give me 2. Or wait, 6 divided by 2. I was looking at the aluminum again. Sorry. 6 divided by 2 gives me 3, so I need 3 carbonates. Looking up at what's projecting on my secondary monitor while also looking down at trying to write on my iPad at the same time. So here, we'll do the charge balance. I have some number of aluminums at +3, plus some number of carbonates at -2 need to equal that 0. And so we get the 2 and the 3, because if I have 2 here and 3 here, I get my +6, my -6, which gives me my 0. There we go. Okay. Calcium borate. So calcium is a +2. And then boron is outside Mississippi, so the 8 is 3 oxygen, so it's BO3. And so remember, nitrogen oxyanions -1, carbon oxyanions -2, and then boron oxyanions are a -3. Okay, so we have a similar charge balance to the aluminum carbonate, except now my cation has the +2, and my anion is a -3, so I'm going to need 3 calciums and 2 borates. Okay, my last one, we have a transition metal. So copper 1 tells me it's a copper with a +1. And then sulfate, sulfur is inside the Mississippi. So my 8 ion has 4 oxygens. Okay, and it does keep that group charge. So sulfur has a -2. So sulfate also has a -2. And so we are going to get 2 of their copper 1s and then 1 sulfate to do our charge balance. Okay, so those are our 8 oxyanions. Now, ite. All we're going to do is subtract 1 oxygen from the 8 and change the ending to ite. So previously inside the Mississippi, we had 4 oxygens for our 8 ending. So now 3 oxygens have our ite ending. Outside the Mississippi, we had 3 oxygens for our 8 ending. So we have 2 oxygens for our ite ending. Okay? All right. So I have a potassium and a PO3. So phosphorus is inside Mississippi. So 3 oxygens is going to be the ite ending. So this is potassium, phosphite. Okay. All right, now I've got magnesium with a boron oxyanion. Okay, boron is outside Mississippi. So outside Mississippi, 3 oxygens is our 8 ending. This has a BO3, so this is a borate. So this is magnesium, borate. Okay. Next up, we have aluminum with a chlorine oxyanion. So chlorine is outside Mississippi. So outside Mississippi, 3 oxygens is 8, 2 oxygens is ite. This has 2 oxygens. So this is aluminum chlorite. Okay. All right, and then we've got another aluminum, this time with an iodine oxyanion. And again, outside the Mississippi box, we've got 3 oxygens is our 8, 2 oxygens is our ite. This has 3, so this is aluminum iodate. Okay? Now, we have some other things going on. For most of these, we're just going to have a couple of groupings of oxygen. When I look at the halogens, though, my halogens can do a lot of oxyanions. They can do 1 oxygen, 2 oxygens, 3 oxygens, and up to 4 oxygens. Now that gets confusing because so far right now what we've done is we've had 2 endings, 8 and ite. So for our halogens, we add in some prefixes. Hypo, with the ite ending, we have 1 fewer oxygen. So this is going to be a single oxygen. Okay? And then when we need more oxygens, we add per, and we add 1 oxygen. So this will be our halogens with an O4. All right, so again, this is only for the halogens. And so per 8, okay, and then we just get 8, ite, and hypoite. And one thing you can use to help keep this in mind is that Per is a shorthand of hyper, and then hypo, these are common prefixes. So if you think of somebody like, let's say blood pressure, somebody that has high blood pressure is hypertensive, and so that's where that per is. Somebody with low blood pressure would be hypotensive. Or like I sometimes deal with low blood sugar, so I'm hypoglycemic, low. So hypo is for low and per is for high. All right? So let's do a mixed bag and let's put all of this together. Okay. So we are starting off with calcium. We've got a ClO3. Chlorines outside of Mississippi. We know outside of Mississippi, 3 oxygens is our 8. So this is just going to be calcium chlorate. Okay. The next one, BRO. So bromine, it's a halogen. So as we just talked about, when our halogens drop down to only 1 oxygen, now we have to start using the prefix. And then we also use the ending "ite" because "ite" is for fewer oxygens. So this is sodium hypobromite. Okay? I know, it's a lot to remember. This stuff is going to take practice. You got to work a lot of these nomenclature problems to start getting it down. It takes a lot of practice. It needs familiarity. Just memorizing flashcards isn't going to do it. You really have to practice these. Okay? All right, then we get magnesium here. IO4. So now, again, halogen. We've just learned that if we go up to 4 oxygens with the halogen, we need that per prefix as well as the 8 ending. So this is going to be magnesium. Per IO date. Okay. All right. So you're not going to learn them if I just tell you all the answers. So I'm going to tell you to pause the video. Try these last 3 on your own before you unpause the video and I give you the answers to them. Okay? Try them on your own. All right. Now see how you did. So this one's going to be aluminum bromate. Okay, and then the last 2 on here, I gave you some transition metals with those Roman numerals, so you would have had to charge balance to figure these out. And so what you should get on this one is manganese 3 nitrite. Okay, and our last one, V, is for vanadium, and so you should get a vanadium 5. Okay, and then it's hypochlorite. Okay, all right. Now here's some names and formulas. So again, not going to learn them if I just tell you all the answers. So before I write the answers down, I want you to try these on your own. Okay, so pause the video, write your ions out, do your charge balancing, see if you can figure these out. Okay, let's see how you did. So we get a copper 1 ion, we get a nitrite ion. Okay, so you should get CuNO2. Okay, aluminum phosphate, we're going to get an aluminum ion, phosphate ion. So there's our aluminum phosphate. Okay, iron 3, and then carbonate. So we should get there we go. So we get 2 of our iron 3s and 3 carbonates. Let's see our calcium hypoiodate, calcium, and then it's just IO minus. So you're going to get Okay. Now, mercury 1 is a polyatomic cation. So this one's weird. Again, I'm only going to make you be responsible for the ammonium cation, but I do want to show you the mercury 1 cation. It does show up every once in a while, so you should be familiar with it. But the mercury 1 cation looks like this, and then our chlorate is like this. And because the mercury 1 cation is a diatomic cation, this is a weird one in that we get this, where they both have a subscript of 2 on them. So you don't need to know the mercury 1 cation. I am not going to test you on the mercury 1 cation. But it's another one of those that does show up once in a while. So I did want to throw it in here just so that you're aware of its existence in case you do encounter it. Okay, and then our last one, our strontium hypochlorite. This is strontium's that +2. And then hypochlorite, so you get, okay. All right, so those are those oxyanions. Okay, now I mentioned some of them you're just going to have to memorize. Okay, so here is that ammonium. All right, there are a whole bunch of other polyatomic ions. These are all I'm going to make you responsible for. So you need to know the oxyanions, you need to know ammonium, and then you need to know the rest of these. Okay, so that's what I will make you responsible for. There's a couple others that you can kind of use clues for. So there's just 2 more here. And that's going to be our thiocyanate and our thiosulfate. And so if I take the cyanate anion or the sulfate anion and I replace an oxygen with a sulfur, it becomes thio. Okay, so what I would recommend doing is having these ions in front of you before you try the next 2 slides, so you start getting used to recognizing them. Again, you do need to know them, so eventually you need to get to them to where they're at a good recall. But when you practice the next couple of slides, have them in front of you, then practice the slides. So I don't know if you want to have, have the slide deck up on the screen while you also have the YouTube video up, or if you print out the slides or whatever. I would highly recommend having this slide and the previous one of the other ions that you just have to memorize before you try the last 2 slides, because I don't expect that you've memorized these all in the last 30 seconds. All right. So formula to name. So I'm going to give you the answers to these. Again, I want you to try them. So pause the video, have those other 2 slides up in front of you, and see if you can figure these out before I just give you the answers. Okay? Okay, hopefully you tried them. So you should get sodium chromate. Okay, here's that ammonium ions. This is ammonium sulfate. Okay, here's another lovely transition metal. This is going to be manganese 2 oxalate. Okay, and then this is aluminum acetate. Barium hydroxide. And here's one of those thio compounds. This is potassium thiocyanate. Okay. All right. So again, start getting used to those. Okay, same deal with this. Try them on your own. Have those lists in front of you while you try them. And then unpause and check your answers. All right, so let's see how you did. So you're going to get, okay, so it should give you RB2S2O3. Okay. calcium, and then peroxide. Right? The most common peroxide you'll encounter is hydrogen peroxide, which is H2O2, which you might have in maybe your medicine cabinet at home. But hydrogen peroxide is the most common peroxide. All right, back to this. Sodium dichromate, so you get a sodium, and then dichromate is the Cr2O7 with a -2, so we get Na2, Cr2O7. Okay, here's that ammonium again, NH4+, and the perchlorate, ClO4-, so NH4ClO4. Okay, K+ for potassium, permanganate is MnO4-, so you get KMnO4. Potassium permanganate is this really cool, like super deep purple compound that comes from some stuff that goes on in the manganese part of that permanganate ion. It's really cool. It looks really pretty. I love this one. I like things that are nice and colored, and our transition metals give us some really cool colored chemistry. All right, and then aluminum cyanide. Okay. All right. So again, practice, 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 practice. That's the only way that you're going to learn these. So that's our polyatomic ions. So we have two more topics to cover with nomenclature. What do we do about acids? And then something called hydrates. So we're almost done with nomenclature. Almost. A little bit more.